Welcome to the deep dive. Today we're jumping into some source material that really gets to the core of how software gets built these days. Frameworks.
Yeah, that's right. We've got this document here. It gives a pretty solid overview, placing frameworks in that bigger context of programming applications.
Right.
Especially thinking about full stack web stuff, good software engineering practices, and, well, industry standards.
Okay, cool. So our goal for this deep dive really is to focus just on what this material tells us. We want to unpack what software frameworks actually are, how they fit into building software overall, and, why they seem to be everywhere. And this material, it kicks things off by making a really foundational point, actually, something that helps clear things up a bit.
Yeah, it draws a line between just programming and the much broader idea of software engineering.
Okay.
It points out that programming, at its simplest, is just writing the code, isn't it? Making the application, translating ideas into computer instructions.
Right, the actual keyboard part. But software engineering, the document says that's way more comprehensive.
Exactly. It describes software engineering as the whole process, end to end, applying engineering thinking, those principles and practices, to get quality software out the door.
So it's disciplined.
It brings that discipline structure, yeah. A method for building applications reliably.
Which means, and the source really hammers this home world, software engineering is not just coding. Coding is just one part of it.
Definitely. It's a tool in the toolbox. And then the material asks, okay, so what else falls under that software engineering umbrella? What are those other practices?
Figuring out what people actually need before you start coding.
Precisely. Analyzing user requirements. Then designing the software based on that, the architecture, how it looks and feels.
Okay.
And talking to stakeholders is huge, right? Making sure everyone's aligned.
And deciding on the nuts and bolts, the structure.
Yeah, choosing the right software architecture, MVC, MVVM, things like that. They structure how the different pieces talk to each other.
That's right.
Plus, picking the design patterns, the algorithms, the technologies, and doing it based on, solid design reasons, not just because it's shiny.
And making sure the thing actually, works.
Yeah.
And is safe.
That's QA, yeah. Quality assurance, testing it thoroughly. Does it meet requirements? Does it perform well? Is it secure?
So it doesn't stop there, does it, once the code's written and tested?
Not at all. Software engineering also covers getting it out there, deploying it, releasing it so people can use it. And then, crucially, the maintenance afterwards, fixing bugs, adding features, keeping it running smoothly. That's all part of the practice.
Okay, so once it establishes that whole software engineering picture, the document makes this really practical point, something anyone who's built, say, a web app probably knows.
Yeah, it notes that most applications, especially web ones, they share a lot of the same stuff. Common features, generic functionality.
Like logging users in, that kind of thing.
User authentication, yeah, perfect example. Or routing requests, figuring out where an incoming web request should go in your code.
Database stuff.
Connecting to databases, talking to them, running background jobs on a schedule, things you pretty much need in almost every project.
And the source makes the point that it'd be incredibly inefficient, kind of pointless even, to rebuild all that common stuff from scratch every single time.
Totally. It's that classic reinventing the wheel problem. Imagine writing a whole new login system or database layer for every single app. It'd take forever.
Right. So the solution that kind of naturally comes out of this, according to the material, is finding a way to package up those common bits, make them reusable.
And that exact need leads us straight into software frameworks. The document actually gives a few different ways to describe them, which helps build the picture.
Okay, like what?
Well, one way is an integrated set of software artifacts. Think classes, objects, components. And they provide a reusable architecture for a whole family of similar applications, like a blueprint, maybe.
A pre-built structure, yeah.
Another angle is seeing it as a coding environment. It's got these low-level libraries built in, designed to handle those common problems we just talked about.
So it helps with the routine stuff.
Yeah, the aim is faster development, often includes templates based on, best practices.
So it's more than just code. It's like a whole setup with guidance.
Exactly. And then a third way it presented is, simpler. Just a foundation or a template.
Right.
Something engineers use to start building. They add their own code on top, personalize it, make it into the specific app they need.
The starting blocks you build on. And it was one-word definition, something about abstraction.
Yeah, that one's quite useful. It calls a framework an abstraction that gives you generic functionality. But here's the key part. That turmeric stuff can be selectively changed or extended by your own code.
Oh,
So
okay.
you write the code that makes it specific to your application.
So the framework handles the common structure, the generic parts, and you fill in the unique bits, the custom logic. It provides the skeleton, you add the muscle and skin. Okay, this is where it gets really interesting, connecting back to software engineering. How do frameworks actually help with those practices, that discipline we talked about earlier?
Well, the document explains they help because they often build in a lot of those good software engineering practices right into their design.
So they kind of guide you towards better structure.
Pretty much. They often embody specific architectural patterns like MVC or MVVM
Yeah.
that help organize your code logically, makes it easier to manage.
Mhm.
They also bring in established design patterns too.
And you mentioned that term, inversion of control. The material flags that as important.
Oh, absolutely crucial. It's listed as a fundamental way frameworks support that structured approach. We definitely need to unpack that one more when we compare them to libraries. That's where it really stands out.
Okay. Do they help teams, like, work together better?
Yeah, consistency is a big one. Frameworks often push for certain standards and best practices.
Like how you name things
Yeah,
or structure your files?
exactly. Naming conventions, coding standards, directory layouts. That consistency makes it way easier for multiple people to jump into the code and understand what's going on.
And just getting a project off the ground.
Tooling support helps there. Frameworks often come with or work really well with tools like package managers.
For handling other bits of code you need.
Right, external libraries or dependencies. And dependency managers themselves, plus things like boilerplate code generation.
Boilerplate.
Yeah, the standard files and basic code you need just to get a minimal project running. Frameworks often automate creating that.
Gotcha. And testing. Is that easier?
Testing support is also mentioned, yeah. Frameworks often make it simpler to write and run tests, helping ensure your app works as expected.
Okay, so that leads perfectly into this really important distinction the source makes. How is a framework actually different from just like a regular code library?
Right, and this is where that inversion of control concept is key. The document really highlights it as the major differentiator.
Okay, let's break down those specific differences it points out.
So first, default behavior. A framework, even before you add much custom code, usually does something. It has a default way it behaves or responds to things.
Okay, so it's not just passive tools waiting for instructions, it has its own flow.
Exactly, which leads to inversion of control. Now this is the big one. With a normal library, your code is the boss.
Right.
Your application decides when to call a function from the library. Your logic drives everything. You call the library.
Makes sense. My code runs the show, calls the library when it needs a specific task done.
Right. But the material stresses with a framework, that's flipped, inverted. The framework is in charge of the overall flow. The framework runs the main loop, handles events, and it calls your code at specific predefined points.
So the framework orchestrates things. And my code is like components that the framework plugs in or calls when needed. The control is reversed.
Precisely. It's a fundamental shift in who's calling whom. A core difference.
Okay. And can you tweak how the framework itself works?
Well, that ties into extensibility. The document says users can extend the framework. You add your code, and often you can replace or override certain default bits with your custom logic.
But the actual, core code of the framework, can you just go in and change that?
Generally, no. And that's the last point. Non-modifiable framework code. You extend it, you plug your code into it, you replace the parts it lets you replace. But you typically don't modify the framework's core source code itself. You work with it, not on it.
Okay, so given that structure, the reusability, that inverted control, why do developers actually use frameworks so much? What's the big draw?
The material lays out some pretty clear reasons. The main one, to make development easier, significantly easier.
How so?
By providing all that pre-built structure, handling the common complex stuff, frameworks let developers focus their energy on the unique parts of their application, instead of constantly messing with the standard low-level plumbing needed just to get any system working.
So you work on the interesting problems, not the repetitive setup.
Exactly. And the direct result of that is usually a big reduction in development time. You're just not starting from zero.
Because you've got that structure, all that reusable code ready to go.
Yeah, you skip past building the foundation every time. It really boils down to that principle. Don't reinvent the wheel.
So besides just saving time, what are the other specific advantages the material lists?
It mentions improved coding quality generally. Things tend to be more organized.
Okay.
Also, easier code reusability, both within a project and across different projects using the same framework, and easier debugging.
Why easier debugging?
Well, debugging inside a known structured environment is often simpler than trying to trace problems in code built completely from scratch.
Right.
There are established patterns.
Right. That makes sense.
Then there's community support. Popular frameworks usually have huge communities around them.
Meaning if you get stuck.
Yeah, chances are someone else has hit the same issue. And you can find help online, forums, documentation, tutorials.
And if you already know the framework, you can really fly, right?
Absolutely. Accelerated development is a huge plus, especially if the programmer is already familiar with that specific framework.
What about performance? Do they help there?
Sometimes, yeah. The material notes frameworks often include things like built-in caching or optimized ways of doing resource-heavy tasks that can boost performance.
And that boilerplate code we talked about.
Right. Frameworks help get rid of needing to write that manually, which is part of enabling faster development with less code needed just to get started.
Any other big wins?
Security comes up. Frameworks often lead to better compliance with accepted security standards. Many security best practices are often built right into the framework's core design, so apps built on them tend to be more secure by default, assuming you use the framework properly, of course.
Okay, so lots of clear benefits. But the source material is balanced. It also points out some limitations, downsides.
It does. It's not all upside. One potential issue is about learning. If you only learn the framework, without really digging into the underlying programming language it uses, you might not get that deep foundational understanding of the language itself.
You learn the framework's way, which might hide some of the language's details or alternative approaches.
Exactly. You get good at the framework, maybe less so at the raw language. Another thing is, when you pick a framework, you're kind of stuck with its limitations and conventions.
You have to follow its rules.
Yeah, pretty much. And that can mean your options for tweaking or customizing certain things might be limited compared to if you built it all yourself.
And frameworks can sometimes feel bloated.
That's another point raised. They're often built to cover lots of different scenarios, so they might come packed with features.
Right.
And you might not actually use all those features in your specific project, so you could be carrying around some extra code weight.
Potential overhead.
Potentially, yeah. And finally, a really important one. Choosing the wrong framework for the job can be bad news.
How so?
If the framework isn't a good fit for what your application needs to do, it can actually hurt performance and make the user experience worse. So that choice is critical.
And just to ground this, the document gives some examples, right? Real-world frameworks.
Yeah, it lists some well-known ones across different tech stacks, like Spring and Spring Boot in the Java world.
Okay.
Express.js for Node.js, which is JavaScript on the back end. Laravel is a big one for PHP.
.NET.
Yep, .NET and .NET Core for C# and other related languages. Django for Python. And then for the front end, the part users see in the browser, it mentions Angular and Vue.js.
Right, using TypeScript and JavaScript. So yeah, they're definitely all over the place. Wow, okay. We really covered a lot of ground from this material. We started with that key difference, programming versus the whole software engineering process.
Yeah, all those steps beyond just the code. Then we saw how frameworks address that common problem of needing the same basic stuff over and over by offering these reusable foundations.
All right, we nailed down what they are, that reusable architecture, the environment, the template, the abstraction you can extend.
And clarified that huge difference from libraries. That inversion of control idea, where the framework calls your code, plus the extensibility versus the non-modifiable core.
Then the advantages came through loud and clear. Faster development, code reuse, community help, performance boosts sometimes, less setup code, better security habits.
But balanced against those real limitations. Potentially shallow language knowledge, being constrained by the framework's design, maybe limited tweaking options, potential bloat, and the absolute need to pick the right tool for the job.
It definitely presents it as a trade-off, doesn't it? Speed and structure versus maybe ultimate control and depth.
It really does. Which leaves us, and you listening, with a pretty interesting thought to chew on based on everything we've unpacked from this source. Well, given that frameworks offer this undeniable speed and structure, but they can limit your flexibility and maybe even impact how deeply you learn the core language, how should you, as a developer or engineer, think about balancing that? How do you weigh the efficiency you gain against the control you might give up or the foundational knowledge when you're deciding how to build something new?